right, good morning, guys. So we're starting, we're starting topic 9. And normally we do everything in the book, but this topic is a little different. So we're only going to use the book tomorrow for SAS 2. The rest will be done today on the notes that I'm going to give you. So grab you some notebook paper and just go along as I go along. All right, so topic 9 is called Rational Expressions and Functions. Okay, so first, before we even start, we are going to define a rational expression. So, a rational expression is that's not how you spell simplified. Is simplified when its numerator, and we know that the numerator is the top, and the denominator, which is the bottom, have no common factor other than 1. Okay? So that means if something on the top, there's something on the top, but it's also on the bottom, we can just cross that out because they cancel. So the first, type of rational expressions is to just simplify. So the first step is to factor the numerator and the denominator. And the second step is to cross out. Now in this case, the second step is the last step. So, just a little hint, every example that we're going to do, the last step you do every single time is to cross out the common factor in the numerator and the denominator. Okay? So, the first example is x squared plus 6x plus 5 over x squared minus 25. Now, in order to factor it out, we want to make it smaller. So first, what do you notice about the top and the bottom? They're both what kind of functions? Well, they're both quadratic. So, the easiest thing that we can do is use this big X that we learned a few weeks ago. Okay? Now, be sure you write this down. So remember, B goes in the bottom, A times C up top. We add to get the bottom, but we multiply to get the top. Okay, so we want to start by factoring out the numerator, the top one. So I'm going to erase this. So my b term goes in the bottom. So remember, my b is my second term, my x term. So it is actually 6. A times c would be 5. So you have to think of two numbers that add to get 6, but they multiply to get 5. So it can only be one thing. And I know what your brain's thinking. Your brain's thinking 2 and 3. But 2 and 3 add to 5 and multiply to 6, and that's the opposite of what we want. So we're just going to go really simple, and we're just going to do 5 and 1. Okay? So for the top, our two factors are x plus 5 and x plus 1. Okay? Now, if we factor the bottom, you see that we are missing a term. What term are we missing? Well, we're missing that x term. So we're missing the b. So if it's missing, we just put a 0 in its place. Up top is a times c. So we have a negative 25. So what two numbers add to get 0, but they multiply to get negative 25? Well, what's the only thing that multiplies to get 25 besides 1 and 25? 5 and 5. But one of them has to be what? One of them has to be negative, so we get that 0. So we have an x plus 5, and we have an x minus 5. So now, what does our second step tell us to do? Our second step tells us to cross out the common factor in the numerator and the denominator. So what is the factor that you see on the top and the bottom? X plus 5. So guess what you do with x plus 5? You literally just cross them out and you write what you have left. So our answer is x plus 1 over x minus 5. Easy enough, right? All right, next we have two more examples of just simplifying. So the next example is x cubed plus x squared over x plus 1. Okay, so first we factor out the numerator. So how many x's are in x cubed? 3. How many x's are in x squared? Okay, so we've knocked our x's out. Now, we're still on the top. How many x's do they each have in common? They at least have how many? They at least have 2. Okay? So I'm trying to get back what I originally started with. So if I have this x squared, but I want this x cubed, what should I add? I should add another x. If I have this x squared and I want another x squared, I just needed to have a plus 1. Okay? Now, we factored out the numerator, so let's factor out the denominator. Can we simplify x plus 1 anymore? Does it have anything in common? No. So, this is the easy part. You just bring it over. Okay? So, we've done step 1. What does step 2 say? What's the last step every time? Cross out the common factor. So, what is on the top that is also on the bottom? X plus 1. So guess what my answer is? You were literally just left with an x squared. Okay? Easy? Hope so. All right. Example number 3 is 4x squared plus 4x minus 24 over x squared plus 3x minus 10. Okay. So first, we want to factor out the numerator. Now, before we factor out, is there a number that we can factor out first? Well, yeah, there's a 4. They all have a 4, something that goes into 4. So we can factor out a 4, and we just have an x squared plus an x minus a 6, because 4 times negative 6 is negative 24. So now I'm just going to bring my bottom down. All right, I'm going to keep factoring. So we can't factor out this 4, so we just bring it down. But we can factor out the top and the bottom. So the numerator, using the big X, we have a 4. Back up. This right here should be an X. Sorry. Should be an X. So when we go back to the big X, what is that number that's in front of that X that I just wrote? Well, just a 1. A times C, so negative 6, and what's in front of this x squared? Just a 1. So we have a negative 6. So remember, we are trying to add to 1, multiply to negative 6. 3 and negative 2. So we have an x plus 3 on top and an x minus 2 on top. Now if we do the big X for the denominator, we have a 3 in the bottom and a negative 10 up top. Well, the only thing that multiplies to 10 besides 1 and 10 is 5 and 2. But something's got to be negative. The 2's got to be negative. So here we have an x plus 5 and an x minus 2. Now, last step every single time is to cross out. What do you have in common on the top and the bottom? X minus 2. So, my answer here is 4 times x plus 3 over x plus 5. Okay, so that was how to simplify. So now we are going to learn the steps to, so this is the second kind, to multiply rational expressions. So the first step is still the same. So it is factor the top and the bottom, also known as the numerator and the denominator. The second step is to multiply the top. The third step is to multiply the bottom. And guess what the fourth step is? The very last step, every single time. Cross out common factor. Okay? So these are the steps. Out besides step 2 and step 3. I want you to draw a little thing like this where they're connecting. And I want you to write multiply equals squished together. And I know you're probably thinking, Miss Ellery, what in the world are you talking about? Like, this is crazy. So, I'm going to show you on the example, but just know when you multiply, you just want to squish them together. You just want to put them all on the top and you want to put them all on the bottom. Okay? So, the first example for multiplying is 2 over x minus 2 times x squared minus 4 over 4. Now, first, can you simplify, looking at the first fraction, can you simplify the number 2? No. Can you simplify x minus 2? No. Looking at the second fraction, can you simplify x squared minus 4? Yes. Can you simplify the number 4 on the bottom? No. So I'm going over here and I'm using the big X because that's a quadratic. And I'm putting my B term in the bottom. But is B there or is it missing? It's missing, so we just put that 0 there. And on top is A times C, so a negative 4. Now, what are the only two numbers that multiply to 4 besides 1 and 4? 2 and 2, but one of them has to be what? Negative. So we have an x plus 2, and we have an x minus 2. So that was step 1, factor the numerator and the denominator. Now, here is where I'm talking about squishing them together. Watch what I do. You see what I'm talking about? I just put everything on the top above the fraction bar, and then I put everything on the bottom below the fraction bar. I put everything together. Okay? So now the last step is to cross out. So what am I crossing out? X minus 2. So I'm left with 2 times x plus 2 over 4. But can I simplify 2 over 4 to what? 1/2. And then I could even write it as x plus 2 over 2. So all I did from here to here was just simplify 2 over 4 down to 1/2. Okay? All right, the next example is x plus 3 over x squared minus 4 times x squared minus x minus 6 over x squared plus 6x plus 9. So you can factor all of these except one. What is the one thing I can't factor? X plus 3. So I'm going to start by factoring the denominator on the first fraction. And we actually just factored it in the previous example. So we had a 0 at the bottom and a negative 4 up top. We have a 2 and a negative 2. So this leaves me with x plus 2 and x minus 2. if we factor the numerator of the second fraction, we have a negative 1 up top, and we have a negative 6. Now, what two numbers add to get negative 1, but at the same time, they're multiplying to get negative 6? Well, we know it has to be 3 and 2, but something has to be negative. This one, the 3. So we have an x minus 3 and an x plus 2. And if we simplify the last one, we have a 6 in the bottom and a 9 up top. And we know that one has to be 2 positive 3s. So we've done step 1. We've factored. Now, the second and the third step, we're supposed to multiply. But what do we write? We squish them together. So on the top, we have x plus 3, x minus 3, and x plus 2. On the bottom, we have x plus 2, x minus 2, x plus 3, and x plus 3. Now, we have to cross out a pair that's on the top and the bottom. So, here's an x plus 3, and here's an x plus 3. Here's an x plus 2, and here's an x plus 2. Is there anything else I can cross out? No. So, we are left with x minus 3 on top, and x minus 2 times x plus 3 on the bottom. Okay, next we have the last example for multiplying. And it is x squared minus 81 over x squared minus 18x plus 81. So, oh, sorry, I forgot the second part. Times x squared minus 9x over 1. So the only thing that we cannot factor out is this one. Okay, so we're going to start by factoring out the numerator in the first fraction, and it's a quadratic, so we can use the big X. So it's missing what term though? Well, it's missing the B term again. So we have a 0 and a negative 81 up top. You know that 81, what two numbers multiply to get 81? 9 and 9, but something has to be negative. 9 minus 9 is 0, okay? So up top we have an x plus 9, and we have an x minus 9. Now, if I do the denominator of that first fraction, we have a negative 18 up top, and we have a positive 81. So, if I have a negative in the bottom, but I have a positive up top, both of my factors are going to have to be what? They're going to both have to be negative. Negative 9 plus negative 9 is negative 18. And negative 9 times negative 9 is a positive 81 because two negatives make a positive. So on the bottom we have x minus 9, x minus 9. Now, last but not least, we have the numerator of the second fraction, and this is a little bit tricky, so pay close attention. So we have this x because it's quadratic. This time, it's missing a term, but it's not missing the b term, so we can go ahead and put our b in the bottom. But it's missing that c term. So if it's missing the c term, we can go ahead and put a 0 as a placeholder. So 0 times this 1 in front of this x squared just leaves me with 0. So now, if I want to multiply to get 0, one of my factors is going to have to be what? It's going to have to be 0 because anything times 0 is 0. So this has to be 0 and -9 so I can add to get -9. Okay? Now, we can go ahead and we can write x minus 9. But, do I say x plus 0? Do I say x minus 0? Really, you don't say either. You know what you can do? You can put a simple x. Because, here's why. Let's say I took both of these factors. And remember, they're factors, but we really want to find the zeros, you know. So I have to originally set them all equal to 0 anyways. So what do you notice about this? You can't solve it. It's already set equal to 0. So anytime you have a factor that's a 0, you just always want to write an x, like I did right here. Okay? So now we factored. So the last thing we want to do, or the next thing we want to do is we want to squish them. We want to multiply them. Now, what do you see in common? X minus 9, x minus 9, x minus 9, x minus 9. So what are you left with on top? Well, you're left with an x plus 9 and an x. And on the bottom, you are left with 1. Okay? Okay. Next, we have the third part, and it is dividing rational expressions. So, first step is always the same. Every time, just like the last step is always the same. So, the first step is to factor the top and bottom, also known as the numerator and the denominator. Number 2, I'm going to write it formally, and then I'm going to give it to you another way too that you'll remember. So rewrite the problem as multiplication by the reciprocal. Okay? Now, if you went to Alamo and you had Miss Mary Kate Gorley in 6th grade, she probably taught you something that was called keep, change, and flip. Okay? So remember, keep, change, flip. Keep, change, flip. Just say that over and over. Keep, change, flip. Keep, change, flip. So you use keep, change, flip when you are dividing. Okay? You can use it when you are dividing fractions. You can use it when you are dividing rational expressions. Remember, keep, change, flip. Okay? The third step will be to multiply the top. Fourth step is multiply the bottom. But remember, that means squish. And of course, the last step is to cross out the common factor. Okay? Keep those steps handy because you're going to need them for this. So, first example is x cubed plus 8 over x minus 2 divided by x squared minus 2x plus 4 over x squared minus 4x plus 4. Okay. I can factor out everything except this x minus 2. So we're going to start by factoring out the top, the numerator on the first fraction. Is that a cubic function? Yeah, so you have to think back and you have to use that sum of cubes formula that we learned a couple weeks ago. Remember, it was a plus b and then a squared minus ab plus b squared for the sum. Okay? So first, we take the cube root of x cubed, and we're just left with x. And then we take the cube root of 8, and we know that is 2. So we're taking x and 2, and we're plugging it into this right here. So we have x minus 2 times x squared minus 2x plus 4. Okay? Now, we're going to try to simplify the numerator on the second fraction. So I've got a negative 2 in the bottom and a 4 up top. Is there anything that adds to negative 2, but it multiplies to 4? I can't think of anything. So that does not work. So this right here cannot be simplified. It cannot be factored. So let's do the denominator of the second fraction. So we have a negative 4 and a positive 4. And that will be a negative 2 and a negative 2. So we've done the first step. Now, the second step formally says rewrite the problem as multiplication by the reciprocal. What did I tell you to remember though? Keep, change, flip. This is for dividing problems only. So we keep the first set. X minus 2, x squared minus 2x plus 4 over x minus 2. So we kept, now we change the sign. So the opposite of division is multiplication. And then we flip the other. Okay? Now, if I want to multiply those, the numerator and the denominator, guess what I can really just do? I haven't been doing this, but I'm going to show you this. You know what you can do? You can just draw this. We can just draw your line all the way across. Just like that. Okay? That's what that means. So now we cross out. What can I cross out? I made a mistake. Look at this right here. Since this said x cubed plus 8, shouldn't this say x plus 2? Yep. Sorry. So go back and change that to a plus. All right, now we're ready. What can I cross out? Well, here's an x squared minus 2x plus 4 on top. And here's an x squared minus 2x plus 4 on the bottom. So I can cross those out, right? Because look, originally they were on top together, but once I kept the first one and I've changed the sign and I flipped the second one, it changed it. So I can cross those two out. I can also cross out an x minus 2 and an x minus 2. Then, what am I left with? An x plus 2 and an x minus 2. All right, the next one is x squared minus 2x minus 8 over x squared minus 9 divided by x minus 4 and x plus 3. So we cannot simplify anything on the right. But I can simplify the first part. So a negative 2 and a negative 8 leaves me with a negative 4 and a positive 2. If I do the bottom, I have a 0 in the bottom because I'm missing that b term, and a negative 9. So I have a positive 3 and I have a negative 3. Now we keep the first one. We change the sign and we flip the last one. So if I want to multiply these together, I'm just squishing it all together. Now I can cross out this x plus 3 and this x plus 3. I keep bringing stuff down wrong. That's supposed to be just bringing it down. X minus 4, x minus 4. Then I'm just left with x plus 2 over x minus 3. Okay, last section is to add or, whoa. Sorry, I don't know what's going on. It's all kinds of messed up. To add or subtract rational expressions. So, how many of you know how to add and subtract fractions? I hope everybody. And not in a calculator, by the way. On paper, with a pencil, no calculator. First step. Factor top and bottom. Second step. Find the least common denominator, also known as the LCD. Third step, rewrite each fraction as an equivalent fraction with the least common denominator. The fourth step is to add or subtract the top only. When you are dealing with fractions, you do not do the bottom. You only do the top if you have the common denominator. So you add or subtract depending on the sign you have. Number 5 is to simplify or factor the new top, the new numerator, and obviously the 6th step is to cross out common factor. Okay, so first example, there's 5 examples, then we're done. First example, x squared plus 4 over 2x squared plus 9 plus x squared plus 5 over 2x squared plus 9 equals. Okay. When you have a fraction, if you're adding fractions or you're subtracting fractions, your denominator must be the same in order for you to continue on. If it is not the same, you must find that least common denominator. In this case, is my denominator the same? Yes. So you don't add your denominators, guys. What does step 4 say? Add or subtract numerators only. Okay, so there's nothing we can do to factor the top. We don't need to factor the bottom. We don't need to find the least common denominator. We need to start with step 4 and add or subtract. So, an x squared and an x squared is a 2x squared. A 4 and a 5 is a 9. So when we bring our denominator over, what do you notice? The top and the bottom are the same, so that just means it equals 1. Okay? Let's see. That was the easy one. Example number 2. 3x plus 26 over x squared plus 6x minus 16 minus 2 over x minus 2. Okay. Factor the numerator and factor the denominator. Can I factor the numerator on the left side? Nope. Can I factor the denominator on the left side? Yes. Can I factor the number 2? No. Can I factor x minus 2? No. So we just need to factor the denominator on the left side. So we have a 6 and a negative 16 So, an 8 and a 2, but one has to be negative. So, we have an x plus 8 and an x minus 2. Now, determine the least common denominator. So, here's how you do this. Look at your denominator. Both sides have an x minus 2. But what is the right side missing that the left side has? Well, it's missing x plus 8. So, in order to make it the same, you must multiply by what you are missing on the top and the bottom. So now my denominator is the same. And it's x plus 8 and x minus 2. On top, we have 3x plus 26 minus 2 times x plus 8. If I simplify that, I have a 3x plus 26 minus a 2x minus 16 over x plus 8, x minus 2. If I keep going, which I must do, I'm moving up here. So I have an x plus 10 over x plus 8 and x minus 2. And that x plus 10 comes from this 3x minus 2x and this 26 minus 16. So this is my answer. Okay? All right, the next example is ten over 3x plus 15 plus 1 over x plus 5. Now, I cannot simplify the number 10. I cannot simplify the number 1. I cannot simplify x plus 5. But I can simplify 3x plus 15. And I'm going to factor out a number. What is the number that goes into both 3 and 15? Well, 3. So I've got a 3, but I want a 3x. So I need an x, and I've got a 3, but I want a 15. So 3 times what is 15? Plus 5. Okay? Now, my denominators are still not the same. The right side is missing something. What's the right side missing? It's missing a 3, so we must multiply by 3 on the top and the bottom. So now the top says 10 plus 1 times 3, and our denominator is 3x plus 5 on both sides. So this is 13 over 3 x plus 5. Okay? All right, next we have five x plus 2 over x squared plus 6x minus 16 minus 4 over x plus 8. So I cannot simplify 5x plus 2. I cannot simplify 4. I cannot simplify x plus 8, but I can simplify x squared plus 6x minus 16. So when I simplify, we just simplified this a couple of minutes ago. So we have an 8 and a negative 2. Now, that right side is once again still missing something. It's missing the x minus 2. So on top, we have 5x plus 2 minus 4 times x minus 2 over x plus 8 and x minus 2. All right, now 5x plus 2 minus 4x plus 8 So when I simplify the top, I'm left with, once again, x plus 10 over x plus 8 and x minus 2. Okay? All right. The next one is x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. Now, I cannot simplify x plus 3. I cannot simplify the number 2, but I can simplify my two denominators. So, on the left, we have a 1 and a negative 2. Well, that has to obviously be 2 and 1, but something has to be negative. So, we have an x plus 2 and an x minus 1. If I simplify the second denominator, I'm missing that b term, and I have a negative 1. So this must be 1 and negative 1. X plus 1 and x minus 1. Now, this is one you have not seen. What is the only thing you have in common on the bottom? These x plus 1s. So, the left side is missing x plus 1 on the top and the bottom. And the right side is missing x plus 2. So here you have to do something on both sides. So now my denominator is the same. It has three factors. It has an x plus 1. It has an x plus 2, and it has an x minus 1. So now we have to combine the top. So we have an x plus 1 and an x plus 3 plus 2 times x plus 2. Well, if I FOIL the first one, or I use the box method, everything's positive. So I'm going to be left with an x squared plus 4x plus 3. If I distribute this 2, I have plus 2x plus 4. Remember, we only combine our top. If I simplify the top, I'm left with an x squared plus 6x plus 7. All of that is over these three factors. Okay, so sorry it's kind of long. I'm going to rewrite all of these notes on paper as well, and I will scan them and upload them so you have them on file as well. Okay, have a good day.